السلام عليكم ورحمة الله وبركاته. أبناء الأعزاء, let us continue our revision. Now we are with problem 1F. I told you before these two graphs in problem F are not isomorphic because the number for circuits of length 4 in graph G are much more than that in graph H. You can deduce this directly. As you see, we just need only two vertices to be on one edge for a polygon of 4 sides or a circuit of length 4, while in graph H we need 3 vertices to be restricted for one side or one edge for a polygon of length 4 or a circuit of length 4. So we have many circuits of length 4 in graph G, more than that we have in graph H, so the two graphs are not isomorphic. Another problem, we have already solved this problem before by transforming graph H to a one similar exactly to graph G. If you remember, in a previous lecture we have already done this and we obtained specific correspondence between the vertices in two graphs, but now we solve it using a new concept. We restrict, inshallah you will understand it very easily. We will use the concept of circuits. As you see, we have 4 vertices and 1, 2, 3, 4, 5, 7, 8, 1, 2, 3, 4, 5, 7 edges in both graphs. 1, 2, 3, 4, 6, 7. So the number of vertices in both graphs is equal. In graph G equals number of vertices in graph H. The number of edges in graph G equals number of edges in graph H. But what about degrees? We can obtain this simply by a circuit like this. We'll try to find a circuit or a path. That visits all the vertices of the graph. Each vertex is visited only once and once only. Okay? How? Like this. Let us try from U2, for example. We can go from U2 to U1, U2, U1, then U3, and finally U4. But we can't return back to U2 because this direction opposes us. Okay? This is called Hamilton path. Hamilton path is a path in which you visit every vertex in the graph once and only once. Okay? This is Hamilton path for graph G. What about the Hamilton path for graph H? Again, we start from a similar vertex like that U2, which is V4. Hamilton path for graph H. Okay, this is Hamilton path for graph G. We start from V4 to go to V4, we go to V3 to V2, and finally V1. We can't go back to V4 because this opposes us. Okay? This is a sequence, a corresponding sequence. Now, what about the degrees? This is the digraphs. So, we have in degree, out degree. Now, for in degree, we refer it by minus, and out degree we refer to it by plus. For U2, as you see, 1 in, 2 in, 1 out, 2 out, 3 out. So, we have for U2, 3 out, 2 in. For U1, we have 1 in, 2 in, 1 out, 1 out, 2 in. For U3, we have 1 out, 2 out, 3 out, 1 in. 3 out, 1 in. Okay? For U4, we have 1 in, 2 in. Very nice. Now, for graph H. V4, 1 in, 2 in, 1 out, 2 out, 3 out. So, 3 out, 2 in. V3 is 1 in, 2 in, 1 out. V2, 1 in, 1 out, 2 out, 3 out. 1 in, 1 in, 1 out, 2 out, 3 out. V1, 1 in, 2 in, minus, minus. Now, this is Zakaziq, this is Mansura, this is Mahalla Kubra, this is Tanta. Zakaziq, Mansura, Mahalla Kubra, Tanta. Now, Zakaziq, yes, Zakaziq, the same. Yes. Mansura, yes, Mansura, yes, Mansura. Mahalla Kubra, yes, Mahalla Kubra. This is Tanta, yes, Tanta. So sequence equal to the sequence, degrees are the degrees. So we have U2 corresponding to V4, U1 corresponding to V3, U3 corresponding to V2, and U4 corresponding to V1. You can check with the previous lecture. So if you want to write the adjacency matrix of graph G, and you write U1, U2, U3, U4, U1, U2, U3, U4, you have for adjacency matrix for H, you write U1 is corresponding to V3, U2 is corresponding to V4, okay? U3 is corresponding to V2, and finally U4 to V1. V3, V4, V2, V1, and you find they are completely the same. Okay? Next problem. Let us look for Hamilton path or Hamilton circuit. For graph H, it is simple to find the Hamilton path from V3 to V1 to V2 to V4. Okay? While for graph G, if we started from U1, we go to U3, U2 can go to U4. This is not a path, Hamilton path. Okay, another choice. From U2 to U4 from U1 to U4 to U2, we can go to U3. So there is no Hamilton path for this graph. Here Hamilton path, here is not Hamilton path, so the two graphs are not the same. Okay? I don't understand. No problem. Let us redraw this. U1 followed by U4, okay, followed by U2, U1, U4, U2. This is U3, from U3 to U2. As you see, this closed. If you go from U1, U4, U2, you can't go to U3. If you go from U1 to U3 to U2, you can't go to U4. So you can't visit all the vertices. You can't visit all, but here we could visit all the vertices once and only once. If the starting vertex the final vertex, this is called Hamilton circuit. But here Hamilton path, not Hamilton circuit. I still don't understand. No problem, no problem. Let us check. We have 4 vertices. 4 vertices. We have 4 edges. 4 edges. But what about the degrees? This is a digraph. So in degree, out degree. Okay? Let's check for the in degree and out degree. As you see, U1 to out, plus plus. U2 to in, minus minus. U4, 1 in, 1 out, plus minus. U3, 1 out, 1 in, plus minus. Now for V. V1, 1 in, 1 out, plus minus. V2, 1 in, 1 out, plus minus. V3, out, out, plus plus. V4, in, minus minus. Oh, the same. How? U1 plus plus plus, V3 plus plus, U2 minus minus, V4 minus minus, U3 plus minus, okay. For example, V1 plus minus, U4 plus minus, V2 plus minus. Oh, they are the same. Oh no, this contradicts with few seconds ago. They are both the same. How? Okay, very simple. First, I told you we have Euler path, we don't have Euler path. No, I don't understand. Okay. Look here. Delta plus plus, Zakazik minus minus. There is a road between them. Okay? Delta plus plus, Zakazik minus minus. Here is one road, direct road from Delta to Zakazik. Delta to Zakazik, there is no one road. So this planning is not the same like that planning. Okay? We have here 3 edges in one direction and one opposing them. Here we have 1, 2, one direction, 1, 2, the opposing them. So completely G is not like H. Okay, so they are not equal. Now let us discuss a new problem. Again, look for Euler path or Hamilton path or Hamilton circuit. Okay? Look here. For graph G, as you see, 1, 2, 3, 4, 1, 2, 3, 4 vertices for vertices. 1, 2, 3, 4, 5, 6 edges, 6 edges. Okay? But what about the degrees. Here there are two digraphs, so in degree I would degree or minus or plus. Now, can we have a path or a circuit that visits all the vertices such that every vertex is visited once and only once? Yes, we can find. Show me where you want to start. I will start from U1 as you like. No, from U2 as you like. From U3 as you like. From U4 as you like. Anywhere you want. If I can find it, okay. If I can't find as a problem, the previous problem, so okay. Now, where you will start as you like. You want to start from U4? Yes, U4, okay. From U4, I go to U2, to U1, U3, then to U4. Oh, I have a Hamilton circuit. Hamilton circuit for graph G. From U4, we go to U2, we go to U1, we go to U3, then back to U4. Okay? What about H? Let us try. We want to start V4. What? V2 as you like. V3 as you like. V1. Okay, V1. Hamilton circuit for graph H. V1 followed by what? V3. Okay? Followed by what? V2. So you will not visit V4. So if you want to start from V1, you have to go to V3, then V4. Otherwise you will not visit V4. No. V1, V3, V2, V1, V4. So you will visit V1 twice. We said you have to visit every vertex once and only once. So V1 to V3 to V4 to V2, okay, then back to V1. Now, as we said, 4 vertices, 6 edges. What about the degrees? Let us look for U4, 1 in, 2 in, 1 out, plus, minus, minus. What about U2? 1 in, 2 out. Okay. What about U1? 1 in, 2 out. 1 in, 2 out. 1 in, 2 out. What about U3? 2 in, 1 out. Okay. Now, for V1 in graph H, as you see, V1, 1 in, 2 out. What about V3? 1 in, 2 out. What about V4? 2 in, 1 out. What about V2? 2 in, 1 out. Now, Zakazik. This is Zakazik? No. No. Okay. Zakazik. This is Zakazik? No. Okay. Zakazik. This is Zakazik? Yes. Banha. This Banha? No. No. So, this cannot be like V4. U4, Zakazik, this is not Zakazik. Okay? This can be Zakazik? Yes, can be Zakazik. This can be Banha? Yes, can be Banha. Zakazik, Zakazik. Banha, Banha. Okay? Qayub, Qayub. Manuf, Yes, move. So U4 is equivalent to V2. Okay? Why? Because U4 is plus minus minus plus minus minus. Must be followed by plus plus minus. Yes, this one. So the sequence U4 is equivalent to V2 plus minus minus followed by V1 plus plus minus followed by V3 plus plus minus followed by V4 plus minus minus. Okay? Now, what is the correspondence? U4 is equivalent to V2. Okay? U4 plus minus minus plus minus minus. Okay? Plus minus plus, we check again. Plus minus plus minus plus. Okay. Okay? So we have a complete correspondence between these two graphs, and if you want to construct the adjacency matrix for graph G, A of G, and you write U1, U2, U3, U4, the adjacency matrix for H must be U1, as we said, will be equal to V3, so V3, U2 corresponding to V1, okay, U1, V3, U2, V1, U3, V4, and U4, V2, V2. Okay? I hope you understood the problem. And we enter the next one, which inshallah will be the last one. This is a problem we have discussed before, and I told you in the lecture they are not isomorphism, and this was an error. I left it to check if you make copy paste in the solution, or you will find that error I left, and you will send a message for me to discuss me. Actually, only one student noticed that, and he sent me an email, and he said I solved it, and it was they were equal. I replied him, and I told him, okay, I'll discuss it with you inshallah, wait a reply from me. And now I'll give you the reply. They actually equal, and as I told you, I left it by myself to check your attention, but alhamdulillah, someone has attention, and okay, now we'll resolve it again. We solved it before by transforming graph G to another one similar, not the same, to graph H. And I told you in the lecture that they are not equal, because I have two circuits here of length 4, but here only one circuit. I remember you I'll make you to remember this. As you see, the circuit from U5 to U3 to U6 to U2 then to U5, this is length 4. Another one from U2, U1, U4, U2, U5, also length 4. So we have two circuits here. While here we have only one circuit. As you see, V5, V4, V1, V6, V5. Okay? Actually there is another one, but no one notes this. Even the student who notes that, he didn't find that circuit. It is simple here, as you see. V1, V2, V5, V4, V1 again. V1, V2, V5, V4, V1. Okay, so two circuits. So, but no one notes this. Okay. Now I will not repeat the same solution. I solve from the original problem. How? As we did previously, let us find an Euler and a Hamilton circuit or Hamilton path in the two graphs. Okay? Let us try together. Where we start, as I discussed with you, try from anywhere and try to find it. If it exists, you will find. If it doesn't exist, you can't find. Okay, where I start, as you like. U1. Okay, Hamilton. I will wait. Path or circuit, it depends on. If the initial vertex is the final one, so it is a circuit. If we can't go to the initial one, it is a path. Okay, for graph G. Now, I start, say, from U1 to, from U1, I'm forced to go to U4. Opposite direction. From U4, where I have to go, you are forced to go to U2. Okay? From U2, where I have to go, you are forced to go to U5. From U5, where I have to go, you are forced to go to U3. From U3, where I have to go, you are forced to go to U6. From U6, where I have to go, you have to go to U2. No, you already visited. But you can go back to U1. So it is a circuit. Hamilton circuit for graph G. Is there a similar one in graph H? Let us investigate. Hamilton circuit for graph H. If there doesn't exist, if it doesn't exist, so the two graphs are not the same. But if they are the same, it does exist. How? Let us try. From where we start, as you like. As you like. Okay, let us follow the same procedure. We start from U1, as you like. As you like. U1. Where I have to go from V1, you can go to either V2 or V6, as you like. Okay, I'll go to V2, as you like, V2. Then, where you have to go, V1, V2. Here, I have to go to V5, I can go to V3. Okay, V5. From V5, where I have to go, you have to go to V4. V4, you can't go to V3. You can't go back to V1 because you would visit V6. So I can't follow this. Okay, again, V1, V6. Nice. Where you have to go? I go to V3 or V5. Okay, if I go to V3, then I follow, go to V4, I can't complete. Okay, so V1, V6, V3, V2, V3, V2. Why not V1, V6, V3, V4? Because this opposes you and you have to go back to V4 and you will not visit V2. Okay, so V1, V6, V3, okay, V2, V5, V4, back to V1. Oh, a Hamilton path again. Now, is this sequence completely equivalent to this? Let's check the degrees. These are digraphs. So in degree, out degree, in minus, out plus. Now, U1, 1 out to in. U4, 1 in, 2 in, 1 out. U2, 1 in, 2 in, 1 out. U5, 1 in, 2 out. U3, 1 in, 2 out. U6, 1 in, 2 out. Let us check again. U1, 2 in, 1 out. U4, 2 in, 1 out. U2, 2 in, 1 out. U5, 1 in, 2 out. U3, 1 in, 2 out. U6, 1 in, 2 out. Okay, now for graph H. V1, 1 in, 2 out. 1 in, 2 out. V6, 1 in, 2 out. V3, 1 in, 2 out. V2, 2 in, 1 out. V5, 1 in, 2 in, 1 out. V4, 2 in, 1 out. Let's check again. V1, 1 in, 2 out. V6, 1 in, 2 out. V3, 1 in, 2 out. V2, 1 in, 2 in, 1 out. V2, 2 in, 1 out. V5, 2 in, 1 out. V4, 2 in, 1 out. Okay. This is tanta. This is tanta? No. This is tanta? No. This is tanta? No. This is tanta? Maybe. Maybe. How? Tanta محلة. طنطا أو محلة. Same. طنطا محلة. This one. منصورة. Yes, منصورة. Yes, منصورة. Okay. زقازيق. طنطا. Okay. محلة. زقازيق. V2 زقازيق. طنطا محلة. Okay. Complete. Here is U1, here is U4, here is U2. Now, after U2, there is, say, Qayyub, plus plus minus, Qayyub, plus plus minus. This is U5. After Qayyub, Shubra, plus plus minus, plus plus minus, Shubra. After Shubra, Giza, plus plus minus, plus plus minus. This is U6. So this is the correspondence between the two graphs. V1 corresponds to V5. V6 corresponding to U3. V3 corresponding to U6. Okay. V3, U6. Okay, V3 plus plus and so on. This is the correspondence we are looking for. Okay, and the two graphs are isomorphism or are equal. Inshallah, I hope you understood the problem very well, inshallah. And inshallah we complete for a new chapter bi'Iznillah, inshallah. Next lecture it is about what we call Euler path, Euler circuit, Hamilton path, Hamilton circuit. I hope when you study the lecture you pay a good attention for listening and for writing. You have to bring with you a pen and paper and write to draw with me, write with me, inshallah, to understand. Good luck and best wishes. Wassalamu alaikum.